Hi guys, Mark here from Marble XPS, and today we're going to be having a look at some of CASA's fantastic mass calibration functions. So if you're working with large data sets and you're looking to calibrate everything to a common feature, there's a couple of really nice tools in CASA to do this, save you a lot of time. So we're going to have a quick look at some of those today. So whether you're calibrating to an individual feature within an unknown, if you're calibrating the carbon, or for example you have a load of nanoparticles on a common silicon support, calibrate to all of the silicons. There's a really nice way of just doing this really quickly, making sure everything's lined up nicely in CASA. So jumping across to CASA now. So we're going to open up a Syria file. So this is some cerium oxide that we analysed, just left the beam on and recorded spectra at time intervals to see how the cerium reduces under the beam. Seems to be some components missing there. Just copy those in so you can actually see how they all line up properly before we go through and do the calibration again. If you're not familiar with the propagation function, we've mentioned it in a couple of videos. We'll go through this a couple of times in today's video. Essentially, if you right click on the actual spectrum, you can bring up this browser operations function. Very useful again if you're working with large data sets. You can apply processing, so things like calibrations, you can apply peak models, regions, etc. all the way down a big data set like this. So we have our kind of T0 and then our, I think in this case about 60 minutes exposure, so T60, so you can see the cerium is reducing. In order to properly model this, we need to make sure that our peaks are all nicely lined up so that we can be sure of any peak shifts or anything. So the first way I want to do this is to do it by just based on a region. So what I'm going to do is come up to processing. I'm just going to make myself a second column so that I don't need to delete the model and put it back in. We'll just do it on a separate block. So in spectrum processing in PCA there's an option called save processed copy, and that will just create another column of cerium 3D data which doesn't have any kind of, there's no calibration, there's nothing applied to this because we've not done any processing on it yet. If you have already done the calibration, then this will apply that calibration before you copy it across. So if we check the calibration, nothing in there. If we line all of these up, you can see they line up quite well because this is the same sample. There was a little bit of shift. These are insulators, so we've had to use the charge compensation system, so there might be a little bit of shift just based on the conductivity or lack of conductivity of the samples when we were doing the measurement. So we're going to calibrate by regions first. So I'm going to create a new region. When you create a new region, you'll probably see something like this, or maybe a 2-guard, whatever the most recent background you've been using is. What I'm going to do is type PR, and that's going to stick in a polynomial regression. So CASA is a really, really powerful software with a lot of mathematical functions, and one of these is a polynomial regression. If we come down to the cross-section box, the first parameter in cross-section will allow you to change the order of the polynomial. So for example, we can go very simple, or we can go a very high factor polynomial, which means we essentially we're just drawing through the data, which is all we really want. We just want to essentially put an envelope through this data the same way we would with a component. For this it's nice and easy because you've only got a single peak to look at. If you're starting to look at some more complex things where putting in components and relying on an envelope might involve a lot of variables and maybe not be the most accurate, then a polynomial regression is really handy at just finding your absolute peak maximas. So that's what we've stuck in, polynomial regression, stuck it around this peak here. So this peak is isolated from the rest of it. There's a lot of overlap between the other species in the rest of the cerium spectrum, so we can look at this one out here on its own to calibrate too. So as I said, we're going to use these browser functions a bit. So I've double clicked on the first one where we've applied our polynomial regression, and then I'm just going to highlight all of the other blocks in this sample. And then if I right click on the spectrum, we bring up this window, and I'm just going to propagate the regions down to the other blocks we've highlighted, and that can take a few seconds, sometimes longer depending on how complex. When you start copying models across, it can sometimes be a little bit slower, but once this is done, we should have that polynomial regression on all of our samples, or on all of our data, sorry. Yeah, so that background's all there. If we overlay these, just going to close this for now. So we've got everything overlaid, and I'm going to come back up to processing. Now in the calibration box, you may have only ever used the calibration function to, for example, click on a peak, bring in this measured value here, and then put in a true value. So here we want 916.7, for example, for this peak here. You can also use the region and component box to drag in the values from whatever region you've got in and whatever component you've got in. And then there's a couple of other options down here. I'm just ticking adjust regions and components, so when we apply the calibration, we also apply that calibration to the regions we've got here, and also the regions we've got in the rest of the model. It's particularly important to tick the regions here when you apply this calibration, because we're calibrating to a region. If you don't adjust the region after the calibration, then Casa can get a little bit confused. So do make sure you tick at least the regions here. Then there's an option down here called apply by row, first region. So if we click this, what we can hopefully see in a second, brilliant, is that these have all now aligned really nicely. You can see that little bit of shift in the data that we had before is now gone. These peaks will now line up pretty much exactly, and you can really see how pronounced this change is down here where we have this introduction of Cerium 3+. So in our processing history, you can see what we've calibrated to. If we scroll down, you'll see that this slightly changes depending on where that region was. And this has also been applied across. So if we have a look at the Cerium 3+ that we originally had, which had no processing, and the Cerium 3+ that we've just done, it's applied this calibration to all of the blocks here, so everything's been calibrated to the same thing. So I'm just going to reset this, remove all of the calibrations, and then I want to just remove all the calibration on everything for now. So I'm just going to type, just going to click on processing, and then because I've highlighted all of the blocks in this sample, we're just going to essentially reset the calibration on everything, so we're back to the raw state, how we recorded the data in the first place. And then we'll have a look at the other way of doing this, which is through the components instead of through the regions. But hopefully you can already see what a useful tool this is if you are working with, say, large data sets where you want to calibrate everything to a common feature, to a common function. Do be careful if you're using this with carbons. Just make sure your if it's adventitious carbon, make sure they are at least mostly chemically similar. If you have wildly different carbon features, well, one's maybe had loads of carbonate, then the polynomial regression might, depending on where you put it, might get a little bit confused about what the peak maxima should be. However, that just goes to highlight what a useful tool calibrating by components is, because in that case you can fit your carbon regions first, fit all of your adventitious carbon, propagate that down, and then calibrate by component, which is what we're going to do now. So if we open up our components tab, again, we're not going to go through the model. We've got other videos which focus on that, but suffice to say, our first peak here, so everything's kind of locked based on this initial peak. So this isolated peak on its own, because it's away from the rest, there's no questions about overlap and how accurate you're getting the peak maxima. We know what this is. It's very important, by the way, that this peak that you're looking at is in column A, because we're going to calibrate to the first component here. So if we come back to our calibration window, this time click component, and what we can see is that it's just dragged this position value from our first component into the measured box. So again, we're just in regions and components. If we highlight everything and again overlay them all, now this is ticked, our true value 916.7, and we're going to apply by row first component, and after a couple of seconds, once again, now these are all perfectly lined up. So CAS has picked up the peak maximum of that component, calibrated to 916.7. So again, if we look at the processing history, we've got all of these individual component maxima that have been pulled out and aligned to 916.7. And the same values, again, have been applied to all of the blocks here. So it calibrates everything, so you don't need to go through and highlight all the individual ones. Overlay everything, apply the calibration by row with the component, and then everything is lined up as it should be. So again, you can do that with serial, you can do that with carbon, whatever you are looking at. Just wanted to highlight what a useful tool that is. So hopefully you did find that useful. Any questions, again, stick them in the box below, and we'll see you soon for another video. Thank you. See you again.